In this next section, we'll talk about how to add the first n terms of an arithmetic series. Now, this only works for arithmetic series, okay? If a series isn't arithmetic, you cannot use this formula. And in the video, I'm not going to derive the formula for you. I might do it in class instead, because it's kind of a cool proof, but we're just going to practice in the video using the formula. So if you want to sum up the first n terms of an arithmetic series, the sum is found by taking n over 2 times the sum of the first term and the nth term. For example, find the sum of this series. All right, so let's count how many terms we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so this is 10 terms. Let's confirm that it's arithmetic. If you check the difference between each of the terms, you'll find that the common difference is 3. So yes, it's arithmetic. That means we can use this formula. All right, so it would be 10 over 2 times the sum of the first term plus the last term. So in other words, it would be 5 times 42. And if we multiply those together, 42 times 5 is 210. Let's try this next one. Find the sum of this series. Well, we're moving up a notch in difficulty, because in the first example, we could count how many terms there were. We knew there were 10 terms. In this problem, we don't know how many terms there are. We know it starts at 20. We know the last term we want to add up is negative 80, but the question is, how many terms are there? Well, to do this, we have to go back to what we know about arithmetic sequences. So we know that the nth term is equal to the first term plus n minus 1 times the common difference. Okay? And so let's take a look here. We can see that the common difference is negative 5. So the nth term, negative 80, is equal to the first term, 20, plus n is what we don't know, but our common difference is negative 5. And so we just need to solve this for n. So negative 80 is equal to 20 minus 5n plus 5. And we got that by distributing. So negative 80 is equal to 25 minus 5n. And now we're just going to keep solving this for n. So subtracting 25 from both sides. Let's take a look and make sure we're careful with our signs. So we have negative 105 is equal to negative 5n, and dividing by negative 5, we find out that n is equal to 21. So what we just found was that this term is the 21st term in the arithmetic sequence. And so when we're asked to find the sum, we're trying to find s sub 21. All right, so we're going to use this formula. So it says that s sub 21, the sum of the first 21 terms, is equal to 21 divided by 2 times the sum of the first term, which is 20, plus the last term, which is negative 80. So I'm just going to write that 20 minus 80. All right, so let's go ahead and work that out. So we have negative 60 times 21 divided by 2, and we have a sum of negative 630. Here's one more example. Evaluate, and we're asked to evaluate the sum of the first 20 terms. So let's start getting some insight into what this series looks like. So when k is 1, excuse me, we have 2 times 1, which is 2, minus 4, which is negative 2. When k is 2, we have 2 times 2, 4, minus 4, which is 0. When k is 3, we have 3 times 2, 6, minus 4, which is 2. When k is 4, we have 2 times 4, 8, minus 4, which is 4. Now, this gives us some insight into what this series looks like. And the last number we would want to add up would be when k is equal to 20. So when k is equal to 20, we have 40 minus 4, or 36. So we could do this by brute force, or we could also notice what kind of series is this. Every time we went to a next term, we're adding 2. So this is an arithmetic series whose common difference is 2. So we can use the formula to add it up. So the sum of the first 20 terms will be equal to 20 over 2, n over 2, times the first term plus the last term. And if we take a look at that, that's 34 times 10, or in other words, 340. Here's one for you to try. Now remember what you're going to need to do. Well, let's do this first part together. Let's verify that this really is arithmetic. From 13 to 21, we would add 8. From 21 to 29, we would add 8. So yes, it does look like this is arithmetic with a common difference of 8. So we're asked to add up the terms from 13 to 77. So the first thing you're going to figure out is, what term number is that in the series? What is n? And then after you know what n is, then you can find the sum. Okay, let's check your work. So to find out what n is, we're going to use the formula for the nth term of an arithmetic sequence that tells us that a sub n is equal to a sub 1 plus n minus 1 times the common difference. So 77 is equal to the first term plus n minus 1 times 8, the common difference. So we simply have to solve this now for n. So here we go. If we keep solving this, we have 72 is equal to 8n. Oh, and so this wasn't that far out. 77 turns out to be the 9th term in the sequence. So we're being asked to sum up the first 9 terms. And according to our summation formula, that's going to be n over 2, 9 over 2, times the first term plus the last term. So let's check out that sum. That turns out to be a sum of 405.